You look in the middle of something, Ed. What's up?
Oh, nothing serious, Tech. There's a slight noise in this torque converter that I'm sure is caused by the converter oil pump.
Well, that gives you a swell chance to explain how the converter works. Bet there are lots of mechanics who'd like to get the servicing lowdown.
That's a good idea. Hey, there's Al now. Let's work on him. Say, Al, you've been around a while, but I don't think you've seen the inside of a converter.
No, Ed, it's a sealed unit. I've had no occasion to get inside. How does it work?
Well, you're certainly familiar with fluid drive. You know it has a driving member called an impeller and a driven member called a turbine. Both work in an enclosed oil bath.
Well, I know that, Ed. Those two units of the fluid drive work like a couple of electric fans placed face to face, with one of them plugged into an electrical outlet.
That's the idea. One fan blows, the second fan turns with the airstream from the first fan. It transmits power without gears. That's the principle behind fluid drive. Now, suppose you grab the air that's normally wasted as it leaves the second fan. That air's still got a lot of push in it, and suppose you piped it back to the first fan. So it would blow against the blades of that fan so as to help the motor driving it. The fan would then blow more air than it normally would with just the motor driving it. Since the second fan would have more air blown against it, it would show more turning effort than the motor puts into the first fan. That's torque multiplication or conversion.
I see.
Fine. Now, getting torque multiplication from a torque converter just means recirculating the oil to get all the use out of it. You see, Al, after oil from the driving impeller forces the turbine around, it surges back toward the impeller. The oil has a lot of push left in it, and where the torque converter differs from fluid drive is in these two stators, or guide wheels, assembled between the impeller and turbine right at the hub. They return oil from the turbine to the impeller, as in the case of the pipe with the two fans.
I see. The stators deflect the oil coming off the turbine back into the impeller.
Yeah, and said another way, the stators redirect the oil so it gives a helping hand to the impeller. The oil fed back to the impeller adds torque to the engine torque, which results in multiplication.
Actually, Al, the converter multiplies turning force up to 2 1/3 times.
Yes, sirree. And the converter delivers extra torque whenever the car needs it, under a heavy load, like up a steep incline. Once the car is rolling under a constant speed, no load condition, there's no torque conversion. The unit runs at about a 1-to-1 ratio, like you'd get with a direct mechanical drive.
Right, Ed. And Al, in between those extremes, the converter automatically supplies the proper torque as needed, depending on speed, grade, throttle opening, and so on.
And not only that, fellas, but you get an automatic, smooth, flexible drive like you'd get if millions of small, progressive gear shifts were possible.
That's pretty clear, Ed. But what about the converter oil pump? The one that's in the support plate?
Well, that pump does two jobs, Al. It keeps the converter full of oil under a pressure of about 30 pounds. Pressure is necessary to prevent cavitation and noise.
Cavitation is a $5 word for air pockets or bubbles getting into the converter to upset the flow of oil in a noisy, inefficient way.
Right. It's something like the prop on an outboard motor. When it grabs air, the prop spins fast and the boat doesn't move.
I get you, Ed.
Fine. Now, secondly, the pump circulates the oil to keep it cool. Cooling is necessary because the converter oil runs at a higher temperature than oil in a fluid drive.
You better show Al how the oil circulates.
Ah, that's a good idea. Here's a sketch showing oil circulation. See? There's the pump drawing oil up from the reservoir. The pump then pushes oil under pressure into the converter. That oil enters the converter through a clearance between the converter hub and stator shaft. The oil leaves the converter through the clearance between the stator shaft and the turbine shaft. It enters a transfer plate passage, which directs the oil through an orifice in the relief valve body and into the external line to the cooler. The orifice backs up the oil when the pump turns slowly. That helps maintain pressure in the converter at idling speed. From the cooler, a line carries the cooled oil back to the reservoir, where the pump picks it up for the converter.
Where's that cooler at, Ed?
Near the front of the engine, Al. Water from the engine circulates through passages in the cooler. In addition, the cooler benefits from the fan blast. And here are those lines from the pump and reservoir to the cooler.
I see. Now, what happens when pressure builds up in the converter?
Why, this pressure relief valve moves off its seat and returns oil to the inlet side of the pump.
Those oil pump jobs sure look important.
That's why we've got to look the pump over carefully.
Righto, Tech. So, getting back to the pump condition on this job, we've got to pull the transmission, clutch housing, the clutch assembly, and the converter support plate.
Right, Ed. And Al, you want to watch a couple of things. First, you drain the reservoir. Then remove it from the clutch housing. Don't drain the torque converter yet. It's easier to do later, and you won't dump that hot oil in your lap.
Good point, Tech. After the reservoir's off, I suppose you take off the starter and the lower half of the flywheel housing.
Yeah, Al. And then's the time to drain the converter. Turn it so one drain plugs at the bottom and remove the plug. After draining, reinstall and tighten the plug so dripping oil won't burn you. Now, we'll disconnect the oil lines from the rear of the support plate. Next, pull the transmission.
Okay, I'll get right on it.
Now, because the rear engine mounts are on the clutch housing, you'd better use this special tool. It hooks into holes in the frame side rails and supports the engine when you remove the clutch housing. Now, to remove the crossmember, first remove the rear engine mount bolts and raise the engine slightly. That'll take the weight off while you remove the crossmember bolts and drop the crossmember. Next, lower the engine about 3 inches so you can get a wrench on the cap screws at the upper part of the clutch housing. Remove the housing attaching screws and remove the clutch housing. Then take out the clutch.
Yeah, Al. And keep your greasy fingers off those clutch facings.
Don't worry, Tech. I'll watch that.
Swell. Now, pull out the converter support plate with the clutch driving plate attached and put it on the bench. Then we'll take the oil pump out of the support plate. Now, to get the pump out, you first remove the 6 screws holding the body to the support plate. 2 of the holes are threaded. That's so you can use 2 special puller screws to pull the pump body out evenly. But before you can do that, we have to heat the support plate. That expands it enough to permit removal of the pump body and stator shaft without scoring the inner surface of the pump recess. A scored recess can cause an oil leak. One safe way to heat the plate is to use 3 or 4 ordinary heat lamps around the outer edge. A blowtorch can be used if you move it around carefully to spread the heat over the entire support plate and not just around the pump recess.
How long is it going to take to expand that plate with those heat lamps?
Oh, about 15 or 20 minutes. Just warm it up so it's hot to the touch.
Say, while that support plate's warming up, somebody better turn this record over. While that support plate's getting warm, we can be checking hub runout on the converter.
Why check that? I thought we were looking for an oil pump noise.
We are, Al, but every time you remove the support plate, you should check converter hub runout before you reinstall it.
I see. One of those always check jobs. Okay. What do we do first?
First, we use a fluid drive wrench to tighten the crankshaft flange-to-drive-plate bolts. Then we use a torque wrench and tighten the 6 drive plate to converter bolts to 17 foot-pounds. Next, mount a dial indicator in either of the lower holes of the clutch housing flange. Line up the indicator follower at right angles to the hub, about a 1/4 inch from the base of the driving lugs. Use a screwdriver between the crankshaft flange nuts to turn the engine. Removing spark plugs lets you turn the engine easier. If runout exceeds 5 thousandths, chalk the spot where the runout's the highest. Bring that chalk mark around to the gauge. You understand that so far?
Still with you, Ed. Carry on.
Good. Now, to correct excessive runout, put a pry bar between the flywheel housing flange and against the head of the nearest converter drive plate bolt. Position the converter slightly to use this bolt head as a fulcrum. Then spring the plate away from the engine.
Be sure you pry on the side of the housing with the dial indicator, close to the chalk mark.
Right. Spring the drive plate about 1/8 of an inch to change hub alignment a few thousandths. After springing it, read the indicator again. Repeat this operation until the hub is within 5 thousandths runout.
Okay, Ed. Now that this hub is all lined up, do we get back to removing that oil pump?
Yes, and here's how that's done. Turning these puller screws alternately, a quarter turn at a time, will pull the pump body up evenly.
That'll also protect the machined recess in the support plate.
Correct, Tech. Once the pump body and gears are out, turn the heat lamps on to keep the support plate warm. Then we can inspect the pump parts and seals. It's always smart to inspect the turbine shaft oil seal ring. If it's broken, replace it. Will you take a look at that? The ends of the pinion gear teeth are worn from rubbing against that pump body island. I suspected that from the noise the pump made.
How'd it sound, Ed?
Oh, like a boy running a stick along a picket fence. I heard it when the car was in neutral and in gear. It sometimes whined because it increased in pitch as engine speed increased.
Pretty clear, Ed. And that condition was caused by the converter hub's excessive runout.
Right. Runout's okay now, so let's fix the pump. First of all, we'll replace the pump body and pinion gear.
Anything special about that?
Well, a new pump body is needed because the bushing in the old one was worn by the runout. And you'll notice the new pump body bore is slightly larger and doesn't use a bushing. That's because the new pump pinion is an oilite gear with a pilot hub to control clearance between the pinion gear teeth and island. The oilite gear doesn't require a bushing. Besides that, we'll replace the transfer plate because of a slight change in design. You'll find this new transfer plate, along with the other parts you'll need, in the parts package supplied for this repair.
I see, Ed. Now, what's next?
Well, this support plate recess shows no scoring that could cause oil to leak past the pump body seal, so let's reassemble the pump. You begin that by cleaning all of the pump parts carefully. Then, always use a new pump body seal. Finally, install the gears.
At that point, Al, use the transfer plate as a straight edge and a feeler gauge to see if there's 1 to 3 thousandths clearance between the pump body and gears.
All right, Tech. This one's okay.
Fine. Now you can install the transfer plate with its large counterbore down over the stator shaft.
Right. Then, holding the pump body by the hub, pour a little oil between the gear teeth for initial lubrication and to prime the pump. Following that, invert the stator shaft and transfer plate and install them in the pump body. Invert the pump and line up the holes.
This support plate's hot. Shall I turn off the lamps?
Yeah, Al. Then we'll install the pump. Use 2 cap screws to keep the holes in line. Center the turbine shaft oil seal ring so you won't break it, and ease the pump into the recess. Use new copper gaskets and tighten the body screws alternately. Torque them all to 17 foot-pounds, and you're ready to reassemble the converter. First, see that both the mating surfaces of the support plate, as well as the flywheel and clutch housing flanges, are clean and free from burrs.
I see. You got to have 4 clean surfaces.
Right. Now, while I hold the support plate, turn the converter slowly. There are 3 different points we've got to index. First, the splines into the turbine. Second, the stator shaft splines have to engage the stator hub. Third, the drive lugs have to engage the slots in the oil pump pinion gear.
Tag all those mating bases, Al. If the support plate is away from the flywheel housing flange about a 1/4 inch, it means the hub hasn't entered the slots in the pinion gear.
Correct, Tech. When that support plate is flush against the flywheel housing flange, you can install the clutch housing.
Okay. Anything else?
Well, make sure the oil connector holes in the support plate and reservoir are clean and free from burrs. And you'd better use 2 new seals on each of the 3 oil connectors before installing the reservoir. Grease the seals a little and put them in. When you install the reservoir, use the 2 short cap screws and spacers at the back end of the reservoir.
Will do, Ed.
Another thing, after you've got everything back together, you're ready to fill the converter. Remove the reservoir filler plug and add the recommended oil to the level of the hole. Put the transmission in neutral, start the engine, and run it at 500 to 600 RPM. Keep adding oil until the level remains at the bottom of the hole. Total capacity is about 10.5 quarts. Then replace the filler plug. After that, shift the transmission into high range. Run the engine briefly at 500 to 600 RPM.
That eliminates any trapped air, and you can check for external leaks at the same time. Then inspect the level of fluid once more.
Okay, Tech. Once that's done, I suppose it's wise to road test the job, eh?
Yeah, that can be a further check on oil leaks, too. After the road test, run the car up on the hoist and check the oil level. If it's okay, there are no leaks.
Where would you look for leaks if the level was low?
Why, at the oil lines and fittings on the left side of the support plate first. Next, I'd look for signs of leaks at the reservoir. If a connector seal was damaged, oil would leak into the hollow of the reservoir and drip through the breather hole in the bottom. Replace the seals each time you remove a connector.
Okay. Any other possibilities?
Well, a leak on the rear side of the support plate usually means the turbine shaft oil seal's at fault. Oil on the front of the support plate can point to the impeller hub seal, the pump body seal, or the copper gaskets.
Say, no wonder we use new seals at all those points.
Here's something else, Al. This reference book contains a lot of good service tips on the torque converter. Be sure to look it over.
Okay, Tech, will do.
Fine, Al. Actually, converter servicing is fairly simple. The sealed unit's just about trouble-free. If you ever run into one that's not up to snuff, the only thing you can do is replace it. In addition, the converter oil pump might occasionally sound off. You can fix it, just like we fixed this one. The only other conditions are oil leaks, which call for replacing seals. Well, that about covers converters.
Yeah, Al. Just go at the job as carefully as you and Ed did, and you'll have no worries about servicing torque converters.